So since we are trying to plot something else which is called a scatter, scatter plot. Uh, so what we need to do is remove this diagram first. Another diagram will appear. So and our scatter, we do that. Then we plot show scatter plot. Then run it. So it's telling us that we are having an error, that we need to input some numpy rec, numpy.rec, rec. So we can also do that and try to run it again. See if this scatter will work. There we have it, our scatter plot. So what the scatter plot answers is that does the increases quantity increases revenue? Are they are there unusual points? So you can see the points. We have 2 points, 1, 1, and 1. So here is the only place where we have 2 points. Then we're going to do a box plot. For us to do a box plot, plot box plot. This is the box plot. I'm going to define what we call total cells inside our box plot, and then box plot title we're going to call outlier detection. We're going to plot title of this box. Call it detection. So if we run it, we get interpretation box equals to normal values, and the dots outside equals to the outliers. So example, a sale of uh, nearly 500,000 may be unusual here. So from here we can find simple sales of 2,000, 2,500 as the highest, and below 750 as the lowest. So that's what we call a box plot. So since we have learned all this, we are going to come to a brief introduction of Seaborn. So since we installed Seaborn and Plotly, so in Seaborn we are going to import here Seaborn. Import Seaborn as import Seaborn as SNS. And Seaborn creates professional looking visualization. Now, first we are going to have a better bar chart. So we can create a bar chart of product and the total sales. So let's go do this, and let's say a bar plot. Instead of a bar plot, let's run data equals to our comma and our x equals to our product and our y equals to our sales. We go to do the estimator and plot. Let's show run this code to expect a bar graph. Just a simple bar graph again, but it's very professional looking. What we can also do is we can count the frequencies of this, and for us to count the frequencies, you can use a count plot. So SNS dot count plot, and inside the count plot, data versus the df, comma, and x versus the region. Since our region versus the regional, it's a capital R for region. It's very important. I'm going to put service for and then I just run this. So what it will show is as which region has the most transaction, which is the north, followed by the southeast, and west almost has a similar transaction. So next, we're going to use our pair plot, which is it's a more powerful EDA tool. And we're going to show the relationship among all numerical columns. So SNS dot pair plot, and what we're doing is the df. So this pair plot and to plot show this the code. And there we have it. It's a very complex one, but it has shows a relationship among all the numerical columns. Very powerful tool. Now, what we can also do is a correlation matrix. So in our correlation matrix is very important while you are dealing with machine learning. So you can come to correlations and plus df correlations. Inside the correlations, you can come to numeric only to be true. So this is a correlation like that. Then we print our correlations. The variable called core. So our expected output shows that highest values have a high relationship. Just as simple as that. Now, the next thing which we are going to do is a visual representation of a correlation. So since you can so for us to see this, we can use a heat map. A heat map is actually a visual representation of a coloration matrix. Now, so we're going to use SNS with heat map. With heat map. Now, inside the heat map, what to do? Do core, the attribute core, and we are not true. Not true. Something like that. And then what we're going to do directly is we're going to plot it directly. We can add some other stuff to it. This is just a very simple explanation. And we run this. So first we are going to print the correlation down here and then expect a visualization of the correlation. That figure shows a visualization of the correlation, and the interpretation is that one, it shows a strong positive, Negative shows a strong negative. Under 0 we have no relationship there. So what we can also do is a distribution plot, as you have seen the correlation and all that. And so just define that correlation. We can do a distribution plot. SMS dot hist plot. Hist plot. And inside the hist plot, and do a df. The df can do something like total size. And we'll do a kda true, and you can plot show this. Plot show this. And then run it. So we expect a histogram and a density curve. I think here is where we forgot our comma. That's it. We can run it again. And there is a histogram with a density curve in the histogram. The density curve is not showing itself correctly. That does not have a problem. So what we can do, the next thing is we can do advanced distribution analysis, where we can create a violin plot. SMS dot violin. Let's say the violin post data df x, put an equal sign, and we give our x as the region, and the y as the total cells. And then we are going to run this. There we have it, which is a violin plot, and it's used to compare distribution between groups. The next step that actually we're going to look at is time series visualization. For us to look at a time series visualization, what they need to do is you need to have the date. can run this. This is simple run. And also what you can also do is you can do something. This converts our dates. Then you can do something on the monthly cells. You can put a monthly definition. Monthly equals df.group by its determinant by df that dot dot month total cells. I choose the monthly cells, and for us to plot this, we can plot the monthly plot. The monthly plot plot title monthly revenue and if you run this, you can display a monthly revenue based on audit. So since this thing was done and all of them was done in 1 month, which is the month of January, look at our cells. It was all in month of January, so the visualization want to be great. Suppose we can change the month, and in a CSS file. Let's put here to be this third month. Put it to the second month, and now file is in this file. Then come to visualize that file, and we run next to our different output. You can see it. So we have the third month here. second month and the first month here. So the revenue of the first month was high since we have 1 month, and the third month was low, was a little bit high. So just a simple view since we have changed the months. Come to our third, where we can save our charts. What was said figures that charts we create something like revenue PNG since it's a photo. It's very useful to have a report. So of course I expect some when I PNG to be inside our chart. Since there is no sales idea, you can just create a file called just like that. Very simple. Then we run it again. It's trying to find it. So first we'll remember that. Look at it. It checks is in the data. Now expect this to be the output. Now the next thing we are going to use a plot line. So for us to use plot line, so we're going to import plot line. Plot line dot express as px. After that we are going to create a chart. Now our chart is going to be in a fig, and we are going to create a bar. Inside the bar we have a df and x to be the product, and our y to be the total sales. And we can feature what we're doing here is figure show, and we run this. So advantages of plotline which is very interactive. What it generates, it's something that you can zoom, you can hover, you can filter, and even you can export it. That's it. There it is. So it opens it in another window. That. So that's where it has opened it. And this is one of the important thing about upload live. And upload live, you can download the picture, you can zoom, you can box select, you can auto scale. Yeah, you can do a lot of things using upload live. Now, this is very important. Mm-hmm. Yeah, very important, and for visualization of data. So we've reached the end of our today. So what I would advise you is do a sales dashboard, a portfolio which has a sales dashboard with KPI cards, which total revenue, total orders, average order value. Then you can do charts which has the revenue by product, revenue by region, the monthly trend, and you can create a correlation and a correlation heat map. The technologies, of course, that you use is pandas, numpy, matplotlib, seaborn, and plotly. So common visualization mistake is too many colors, and good you have a simple and consistent palette. The thing is wrong chart type. Using a pie chart for like 50 categories is a very wrong. Let's say therefore 50 categories you can use a bar chart. The third thing is missing labels. Always include the title, the X label, and the Y label. So there's a mini challenge where you can find the top selling product which you can visualize through a bar graph. You can find the best region, you can visualize that through a pie chart, and you can create a monthly sales trend using a line chart. You can create a correlation heat map which you can interpret as strong relationship, and you have to a correlation heat map as a distribution curve and a histogram. So from the above, we have learned how to create a professional chart, to perform explanatory data analysis, to detect trends, to find outliers, to analyze correlations, and to build dashboards. You can build even a dashboard out of it using Plotly and present insight to stakeholders. So, so in the next steps, we can just look at a few statistics of data science, where we can look at the mean, mode, and the median, the variance, the standard deviation, probability, normal distribution, hypothesis testing, and the confidence intervals, A to B testing. This concept will be very essential for us moving forward into machine learning.